Cercon Smart Ceramics, the zirconium oxide all-ceramic system. The system comprises the scanning and milling machine Cercon Brain, the suction unit Cercon Clean, the sintering furnace Cercon Heat, and the CAD module Cercon Art. The ceramic blank Cercon base are available in white and ivory color. They can be used for crown and bridge framework up to 47 mm anatomical length. Also part of the system is the veneering porcelain Cercon Ceram Kiss. In this video, you will see how easily and quickly you can fabricate aesthetic zirconium oxide bridge framework with the Cercon system. We start at scanning this model for a 6-unit anterior bridge. Model and holder of the new scanner Cercon I are adjusted using the template so that the insertion path of the bridge is near enough vertical and the highest model elements just touch the template. In the software, the first step is to determine the bridge design. In order to capture all dies completely, they are digitized one at a time. The user is guided step by step through the program. Using the crosshair in the video preview, each die is positioned. Then the lid is closed to start scanning. Here we are using a trick to leave it open for filming. Scanning takes about 15 seconds per die. The time for the following scan data calculation can already be used to insert and scan the next element. After the last element has been scanned, all point clouds are assembled based on the reference markers, resulting in the complete virtual model situation. The result is displayed as a point cloud showing clearly that proximal areas and undercuts are well represented. Cercon Move was developed for intuitive and simple orientation of the virtual models on screen. With this device, one moves the object with one hand and works on it with the other using the PC mouse. The 4 scroll wheels of Cercon Move enable separate motions, moving along the tooth arch, tilting about this arch, turning around the screen center and zoom. Before preparation lines are determined automatically, the point cloud is reduced slightly from the basal side. After the calculation, the model is displayed with the preparation lines. A manual editing function for correcting or manipulating the prep lines is under development. The bridge framework is initially calculated based on standard settings. This design proposal can be changed in several steps. Soon, it will be possible to use data of antagonist and neighboring teeth to evaluate the correct anatomic framework shape. The optimal framework manipulation is divided in 6 logical steps. The Pontic manipulation offers a large variety of modifications, including selection of alternative tooth forms, positioning, and changing the size. The menu offers moving, rotating, and scaling relative to the 3 tooth-related axes. While the Pontic is being adjusted this way, Cercon Move supports checking it from all angles. The basal pontic contour can also be modified in various ways. The parameters are easy to understand since all changes are instantly visible. An automatic adjustment of the basal surface provides a constant gingival distance for veneering as set by the user. Connectors are modified in the last step. They are automatically fitted and connected tangentially to the neighboring surfaces. Position and size can be adjusted interactively in basal buccal and vestibular oral directions. Thus, the required connector area of 9 square millimeters can be achieved without aesthetic compromises, even for anterior bridges. After completing the CAD modulation, we proceed to the CAM chapter, where the local Cercon brain is selected for milling. Other milling options are a remote Cercon brain or Degodense network production Compartis. As a next step, the blank-size Cercon base 47 is selected for milling. The bridge is automatically placed. Rough milling works in the usual meandering fashion. During fine milling, the inner coping surfaces are milled circularly to ensure an optimal fit. Like with single copings, a membrane around the framework forming the connection is perforated as the last milling step. The complete milling process for this bridge took 40 minutes. After sintering, only little fitting work is required for the framework to achieve an excellent fit.